And once again, need to read this. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in a Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Okay. Today we're going to go on and take a look at section 6.4. But first, are there any questions from last night, which was 6.3 using the trial and check method?
I didn't have any.
Okay, and apparently it's just you and me today, so no questions. We'll go on to 6.4.
Perfect.
All righty. So 6.4, we're going to look at two ideas. One of them is still dealing with trinomials, but special cases of trinomials. And first of all, I want to talk about, or maybe hopefully remind you, what a perfect square is. 0 times 0 equals 0. 1 times 1 equals 1. 2 times 2 equals 4. 3 times 3 equals 9. 4 times 4 equals 16, etc. These numbers are perfect squares, meaning that they have two identical factors. All right? So if we have, let's say, x plus 3 times x plus 3, and we FOIL that all together, we get x squared plus 3x plus 9, which is x squared plus 6x plus 9. Since that trinomial has two identical factors, we say that this trinomial is a perfect square trinomial. Now, what's so convenient about a perfect square trinomial? Well, again, it has two identical factors, so when we go to factor it, if we're thinking it might be a perfect square, we're thinking two identical factors. So whatever I have over here, I'm going to have the same thing over there, if, in fact, it is a perfect square. All right, questions about that?
No.
So let's take a look at some examples. Let's go back to that one we just started with. X plus 3 times x plus 3 is x squared plus 6x plus 9. X minus 5 times x minus 5 would be x squared minus 10x plus 25. I'm skipping the steps of foiling it together, just wanting to get to the answers. X plus 7 times x plus 7 would be x squared plus 14x plus 49. Okay, so again, I'm skipping the steps to get there, but those would be the resulting perfect square trinomials. Okay, now I want to look at a pattern. Notice that each one of these perfect square trinomials starts with a square and it ends with a square. All right? Now, positive times positive gives you a positive. Negative times negative gives you a positive. Positive times positive gives you a positive. So if a trinomial is a perfect square, it has to start with a square, end with a square, and in front of that second square, there has to be a plus sign. So for instance, if I have something like this, x squared plus 7x minus 25, that's a square, but that's a subtraction sign. There's no way there could be two identical factors because you'd have to have a plus sign there. Does that make sense?
Yes.
All right, now, the author explains it even in greater detail, dealing with the middle term. My experience has been it's more confusing to students at this point, so I just kind of leave that off, and what I do is I say this. If we're looking at a trinomial and we're investigating whether it's a perfect square, we're going to look at the leading term and make sure it's a square, and the last term and make sure it's a square, and then make sure there's a plus sign in front of it. If all that fits, then we'll go forward assuming it is a perfect square finding out whether it is or not. If any of those three things fail, we know it can't be a perfect square, and we'll try other means of investigation. All right? So let me put on my glasses here, and let's take a look at some examples. X squared plus 14x. Is that one I just used? Yes, it is. Let's do a different one. Let's see. Y squared, 9y squared rather, minus 30y plus 25. All right. So first of all, this is a trinomial. It's in standard form. There's no greatest common factor. Now, the leading term has a coefficient that's not a 1. So based on what we did yesterday and the day before, we would go through and factor this either using the grouping method or the trial and check method. Well, both of those take a bit of time. So before we do that, let's look and see if this could be a perfect square trinomial. 9y squared, that's a perfect square. 3y times 3y. 25, that's a perfect square. 5 times 5. And it has a plus sign there. So far, so good. So I'm going to assume it's a perfect square, and I'll find out here if it is or not. If it is, I need the leading term of each binomial factor to be the same. So 9y squared would be 3y and 3y. Again, you following that okay?
Yes, that makes
Right?
sense.
25 would be 5 and 5. But somehow I need to get negative 30y in the middle. Well, plus 5 times plus 5 would give me plus 25. But then I wouldn't get minus 30y. So these two signs have both got to be negative to get a negative term in the middle. Let's find out if this is true. That's 9y squared minus 15y minus 15y plus 25. 9y squared minus 30y plus 25. Cha-ching. So it is a perfect square, which means I could write it that way, or I could write it using a exponent of 2. Okay with that?
Yes.
All right. Let's see here. 9a squared minus 48a minus 64. So if this is a perfect square trinomial, we'll factor it. If it isn't, we'll leave it for later. It starts with a perfect square. It ends with a perfect square. But there's a minus sign there. So it is not a perfect square trinomial. Now, it might be factorable, but I want to just focus on the perfect squares right now. So not a perfect square. So we'd have to go back and use grouping or trial and check to see if we can factor it. Okay? Let's see here. 121 plus 4x squared plus 44x. Let's see if we can factor this. Well, it's a trinomial, but what's wrong with it?
Is it that 44 isn't a square?
Well, that's
Or,
true.
and then it's not in descending order as well.
Right, standard form. Good job. That's the problem.
I was looking at it wrong. Never mind.
That's okay.
You got the 44 wrong.
Yeah. So now it's ready to analyze. Does it start and end with a square?
I'm not sure about 121 off the top of my head, but from what it looks like, yes.
Okay, well, let's see.
Oh, wait, is it 11?
There you go. Bingo.
Yeah.
So it looks, let's see, this would be what? 2x and 2x and 11 and 11. Okay. Would it be?
would it have to be a positive since
Yes, it
the
would.
middle number is positive?
Yes, it would. Good job.
Okay.
So let's see if that works. That gives us 4x squared minus, plus 22x plus 22x, and then plus 121. So 4x squared plus 44x plus 121. So yes, and we could write it that way, or again, we could write it that way. All righty?
Sounds good.
Okay, let's do one more of these. Let's see, 3v squared minus 42v plus 147. So let's see. Is this thing in standard form?
Yes, it is.
All right. It doesn't really look like a perfect square, does it?
Based off of the first coefficient, the 3, not that I know of, it's a perfect square.
So I'm going to say it's not a perfect square yet. What's the next step?
Are you gonna factor? Or
Yeah.
no idea.
What?
Show me an example, please.
Ah, come on, you can do this. What is okay? What's the next thing we do? Even if it was just back in the last section, after it's in standard form, what do we look for next?
I see what's the greatest common factor.
Bingo! There you go. So, what's the greatest common factor?
Is it 3?
Yeah. Do you remember how to tell whether 3 goes into a number?
You see if they all add up together. So like 4 and 2 is 6, 3 goes into 6, and then 1, 4, and 7. Does that equal up to a number divided by 3?
I don't know. Does it? What's 1 plus 4 plus 7?
6 and that's 11, so it doesn't.
Wait. Try again.
So 1 plus 4 is 6. 6
Wait,
and 7 is 13, right?
Wait. 1 plus 4 is what?
Oh, 5.
There you go. I know,
So
you're thinking.
it's because when I get put on the spot, I get really nervous. So
I know,
12.
sorry.
So 12.
I know, since you're the only one here, there's no one else to pick on.
That's okay. I get to learn. So
Okay. And I can,
12.
12, all right. And if I'm picking on you too much, let me know and I'll just pick on myself.
No, it's okay.
So we're going to take out a 3. So we're going to get v squared minus 14v plus 49. Okay. 3 times 14 is 30 plus 12 is 42. 3 times 49 is 120 plus 27, 147. All right. So is what's left inside, does it look like it might be a perfect square?
Yes.
So we'd have a V and a V and a 7 and a 7, and what else?
And then would it be, since it's a negative, would it be 1 positive, 1 negative, or would they both be negative?
All right. If it's a perfect square, they have to be identical.
Oh, so then they'd be negative, right?
Yes. Because negative times negative would give you the positive 49, and we'd have to have the minus 7v minus 7v to get the minus 14v.
And then for that one, for the or writing, would it be 3 parentheses v negative 7 square?
Bingo.
Okay.
All righty. Good job. Good job. Okay. So that's the first half. That's dealing with perfect square trinomials. Now we're going to look at binomials, so 2 terms. And to do that, I want to start by going back to something that is in chapter 5 of this book, where we learn to multiply or FOIL together polynomials. Let's say I had x plus 5 times x minus 5. So now this is not going to be a perfect square because the factors are not identical. Okay? In fact, they're what is called a conjugate pair. You've got the sum of 2 numbers times the difference of the same 2 numbers in the same order. If I FOIL this together, I get x squared minus 5x plus 5x minus 25. But when I go to simplify further and I combine like terms, the middle terms cancel out. And I end up with a binomial. So I took a binomial times a binomial and still got a binomial. And this answer is what we call the difference of two squares. Difference as in subtraction. Two as in there's a square up front and a square at the rear. So we're subtracting two squares. It's called the difference of two squares. Now, what I want to do further with this, notice that when I FOIL it together and I get this, what I have there is a square minus a square. What's the base of that square? What is being squared?
X.
What's the base of that squared? What is being squared?
Y.
Well, those two numbers are the same as those two numbers. So the numbers that are squared in the answer are the numbers that are added and subtracted in the factors. So what am I saying? I'm saying this. Let's say we've got x squared minus 49. Is that the difference of two squares?
Yes.
What would the first base be?
It would be X.
And the second base?
Off the top of my head, I want to say 7.
Well, then say it.
7, I think, because I haven't done squares in a long time, but I kind of remember.
You are correct. So I'm going to get the sum of the two bases times the difference of the two bases. So this is factoring. This is not the factoring process. It's just identifying, convincing yourself that, yeah, what I'm looking at is the difference of two squares. Okay?
So you want us to write it where you have the two arrows, not the one that's circled?
This is the answer.
Okay,
You can choose to do this or not on your own to see what the numbers are going to be. In other words, that's not the answer, but that's just a process I use and encourage people to make sure. Okay?
Okay.
Let me explain why I do that. Let me give you another example. 4y squared minus 9. Okay? Is that the difference of two squares?
Yes.
So what's going to go inside the first factor?
It's going to be 2y. And then 3. And then the other one would be 2y and 3 as well.
Correct. And you did it. You did it correctly. What I've had students do is they'll write 4y plus 3. 4y minus 3. Because they don't think about the fact that the whole thing has to be a square. So the reason I do this is to hopefully force them to think about it a little bit more. What's going to be there? It's not going to be 4y. It's going to be 2y. You don't have that problem, but some of the students have had. Okay?
Okay.
That's kind of why I go off to the side and say, well, let's think this through. All right. How about this? 49 minus w squared. Is that the difference of two squares?
Would it be yes, because you would flip it around?
Let's not even flip it. Well, hold it. If we flipped it,
if it has a negative, would that matter?
Well, let's go back a little bit. You said flip it around. That would give you this, right?
Yeah.
Is that the difference of two squares?
I don't know because of the negative in front of the W, but yeah, the 49 is a square and it has a plus, so that makes sense, but I'm still kind of iffy about the negative in front of the W square.
Yeah, written in this form, just as it is, it's not the difference of two squares. But coming back here, this is. So in the binomial, rather than focusing on standard form, I'm going to focus on, can I write it like this? So I could write 7 plus w, 7 minus w. Okay? Does that make sense?
Yeah, that makes more sense. I was just kind of confused when I seen it that way. I was like, wait, I don't know about the negative.
Okay, now, erase this. Come on. Lovely, lovely, lovely. 3 hours later. Let's do what you first suggested, okay? Because going this way isn't wrong, it's just long. So I have a binomial, and we've put it in standard form. But the leading coefficient is negative. Remember how we talked about when you're factoring, you really want that leading coefficient to be positive?
Yes.
So what I would do is I would factor out a -1. See what I did there?
Yeah, but then would it be the same steps after that?
So now what's inside is the difference of two squares.
Mm-hmm.
So this is a correct answer. That is a correct answer.
It's just a longer process.
Exactly. This is more, let's go by the rules and put it in standard form and da, 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 da. But the rules, as you'll see when I give you the whole list, is that if it's a trinomial or larger, standard form is important. If it's a binomial, you're more concerned about, can we write it as a difference than is it in standard form? Okay?
Okay.
But in fact, in the textbook, these are both listed as a correct answer. So you could go either way with it. Okay?
Okay.
All right. Let's see here. How about this one? H squared minus 144. That's a binomial. Is it written as a difference?
No.
What do I mean by a difference?
Do you mean like how we just did it, like put them in their own parentheses, or do you mean the way it's formatted as of now?
Okay. 7 minus 3. That's a difference.
Mm-hmm. Oh, then yes.
Because
Yes.
you're subtracting.
Yes. Yes.
Okay. So it would be what? H squared minus 12 squared. So H plus 12, H minus 12. All right.
Got it.
Let me ask you this. What about H minus 12 times H plus 12? Would that also be correct?
Yes.
Why?
From the last chapter, you mentioned that whether you put negative or positive first, it's gonna. I don't remember the correct term, but it'll still multiply correctly.
Okay.
Or no?
If we were at school, at the building, you would drive to school, take your class, you drive home, you drive to school, you drive home, you go back and forth. What do you call that, going back and forth?
Commuting.
Bingo. Multiplication is commutative.
Commutative. Yes.
Right,
Yes.
commutative. It's like the cow says commutative. Yeah, whatever. So if we can change the order of the factors.
Okay.
There you go. All right, commutative. Let's see here. How about this one? 49d squared minus 16. Does that look like it's the difference of two squares?
Yes.
So what?
Wait. Yes. 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 Yes.
Okay. What would the first base be?
7D, and then 4 and 4.
Yeah. So again, this is just kind of help things along. You don't have to do that, but if it helps to get the 7D instead of 49D, but you were fine with it. Okay. I always just like to put the positive and then the negative, but you can switch them around since the rest of it is identical. Now, notice, these are not identical factors. So you can't write it as 7D plus 4 squared or 7D minus 4 squared. Okay, can't do that because they're not identical factors. It's not a perfect square trinomial. Okay?
Got it.
All right. What about this? X squared minus 27.
I don't know if 27 is a perfect square.
All right, tell you what. Have
Not
you
that
got
I
a
can.
calculator?
Yeah, not on the top of my head. Yes.
So put in the
20.
square root, take the square root of 27, see if you get a nice number.
I have that scientific calculator, but it's been a while. Let me see. Second, 27. Okay,
You
I'm
should
not
get
doing
like 5 point something.
27. Yeah, 5.19.
Okay, so it's not a perfect square, is it?
No. So prime.
Yep.
Okay.
How about this problem? 3x squared minus 27.
It wouldn't be.
Now, I
either
need to warn
way.
you. I need to warn you, I'm trying to trap you here.
Oh, okay.
Careful. I'm trying to trap you. Watch out.
Okay. Well, this one is okay. But 3 isn't a perfect square and 27 isn't either. So how would you do that?
You
Or
tell
am I
me.
overlooking it?
You're overlooking something.
Gosh, what's the word? When you factor out the 3 and then you would get
Yes. What do you call that 3? We're factoring out the
greatest common factor.
bingo. Good job. And that's why you always want to take out the greatest common factor before you start looking for perfect squares or difference of 2 squares or whatever, because it may trick you.
Okay. Yeah, I see that.
All right.
After a minute.
That's okay. Excellent. Excellent. Okay, let's see here. How about this one? 4x squared minus z to the 4th power. It's a binomial, right?
Yes.
It's got a subtraction sign in the middle, so it's the difference. Is 4x squared a square?
Yes.
Is z to the 4th power a square?
Yes.
Good. So what would the base be for 4x squared something squared? What would go inside?
It'd be 2x.
Okay, and what
For
about the
both of
second?
them. And then one would be plus and one would be negative z squared.
Z squared. Good. So yes, 2x plus z squared, 2x minus z squared. Okay. Now, are we done yet though? Let's take a look at this factor. Isn't that a binomial?
Yes.
Is there a subtraction sign in the middle?
Yes.
Is z squared a square?
Uh-huh.
How about 2x? Is 2x a square?
Yes.
Now
No.
you've gotten
No.
suspicious of me. You think I'm trying to trick you.
Wait. Well, 1x times 1x would be 2x, right? No. Yes. I don't know.
No, it would just be x squared.
Okay.
Yeah. 2x is not a square.
Okay.
So we're done. But I'm setting that up because I'm going to give you another problem where we won't be done yet. So this would be the final answer here. Okay. But I'm just having too much fun torturing you today.
No, it's fine. I
know.
learned the visual way, so when you write it out, it helps a lot.
That's great. That's great. Okay. Take a look at this. Y to the 4th power minus 625. Okay. So this is a binomial. It's in standard form. It has a subtraction sign in the middle. Is it the difference of 2 squares?
Yes.
All right. So how would you write y to the 4th as something squared? What would that base be?
Y is squared.
Okay. How about 625? Pull out that calculator.
25.
Good
Already
job.
ahead of you.
Okay. Good job. Good job. So that means I'm going to have y squared plus 25 times y squared minus 25.
But this one has, on that second one, is that the one you were talking about?
Yes. Good job.
So what would you do after that? Because
So,
it is a perfect.
okay, that doesn't factor further because it's a sum, it's not a difference. This would be y plus 5, y minus 5.
And that would be your answer?
Well, let's see. Here's a binomial with a subtraction sign. But is
Another
that
one.
the difference of 2 squares?
Yes.
Is it? Is
Wait,
y
say
squared?
it again. I'm sorry.
Okay, is this y minus 5, is that the difference of 2 squares?
No,
No.
because y isn't squared and -5 or 5 isn't
Right.
either.
Correct. So we're done with this problem.
Mhm.
Okay.
Okay.
But notice I factored it and then I factored that further.
Yes, correct.
It ain't over till it's over, kind of thing.
Okay.
All right. Now, let's see. What was it I wanted to do? I want to look at.
I have a question now that I'm
Yeah.
looking at that problem.
Yeah.
So for the first one where it says y squared plus 25, that one we can't factor out anymore because it's not a difference, right? Or why can't we factor that one out further? Because it's not a difference?
That's part of it. There's no greatest common factor we can take out, and it's not a difference. So if it's
Okay.
right, so it's
Perfect.
that's as far as we can go with it.
Okay.
Okay. Now, what about this? B squared plus 25.
Well, that's not a difference of 2
Right. So
squares.
here we've got the sum of 2 squares, right?
Yes.
But it doesn't factor. So this is prime.
Okay.
Now, I'm going to make a statement, and then I'm going to sort of add on to it. Okay. You can't factor the sum of 2 squares. I'm going to finish that in just a minute. Okay, just hold on. Is that the sum of 2 squares?
That's the sum of 2 squares.
Can I factor it? Yes, because
Yes.
I can take out a greatest common factor.
Mm-hmm.
But now what's left, the sum of 2 squares won't factor. So now let me go back and finish that statement. You can't factor the sum of 2 squares once you've removed any greatest common factor. Okay, so here there's no greatest common factor, it's prime. Here, that's the sum of 2 squares. After you take out the greatest common factor, what's left doesn't factor further. But you've always got to check for that greatest common factor first. Okay?
Okay.
All right. In fact, let's see. Yes. I'm going to give you a list. Now, if you have the textbook, the actual, textbook, not the ebook, this list, let's see, where is it here? They have it on page 477. It says a factoring strategy. That's in 6.6, which is coming up. I think that's going to be Monday. Okay. But I'm going to go ahead and sort of give you the list now. And this is what it looks like. Okay. Item number 0.5. I know that's kind of a strange way to start a list. I will explain. I'm going to say standard form. Okay. Item number 1. Take out greatest common factor. Item number 2. Oh, wait, I need to put it. Binomial. Take out. Wait. Sorry. Binomial difference of 2 squares trinomial. And then I'm going to have Roman numeral 1, 2, and 3. And 1 is going to be perfect squares. So perfect squares. So I'll write x plus a squared. 2 is going to be x squared plus bx plus c. And 3 is going to be ax squared plus bx plus c. And I'm going to say a, b, c, p, s, or grouping, or that's the what, guess and check. And then 4 is factor by grouping. 5 is check your, wait, not check your work. Sorry. 5 is are you through? And 6 is check your work. Now, let me go through and explain this. Sorry, I kept messing things up. I haven't had to write this out in a long time. I had a sheet of paper I just flip out there. So, standard form, that's descending powers, okay? That's 0.5. Now, item number 1, take out the greatest common factor. So you want to do that before you do anything below that. Item number 2, binomials have 2 terms. Item number 3, trinomials have 3 terms. Item number 4, factor by grouping has 4 terms. And check, are you through, and check your work. So I'm going to do a little more here, and I want to put this and draw an arrow down here. And I know this seems kind of a crazy thing here, but if you're dealing with a trinomial standard form, a trinomial or bigger than that, 3 or more terms, standard form is really important. But if you're dealing with just a binomial, then you're more interested in having it be written as a subtraction rather than standard form. Remember that one example we looked at earlier? What's that? This one right here, where it was easier to leave it that way than to put it in standard form. Okay.
Yes.
So trinomials and on, you want standard form. Binomials, look for difference of 2 squares. But before you do any of that, take out your greatest common factor. Okay, now, what's this whole thing here, Roman numeral 1, 2, and 3? So 2 days ago, we looked at section 6.2, and we looked at trinomials where the leading coefficient was a 1. Yesterday, we looked at trinomials where the leading coefficient was something that's supposed to be an A, something other than a 1, and we went through and either did grouping or guess and check. Today, we looked at perfect square trinomials. Well, when you're trying to determine how to factor a trinomial, it doesn't take long to determine whether it's a perfect square or not. So that's the easiest thing to analyze. So check for that first. If it's not a perfect square, but it has a leading coefficient of a 1, then you're going to do that next, because where you're going to take the x squared or whatever it is and break it up into the starting terms of each binomial factor, and then you're going to do the product sum, the last number, the middle number. Then the worst case is where the leading coefficient is a number other than 1. That's when you go through and do the grouping or the guess and check, okay? You don't want to do grouping or guess and check unless you have to, because it's more work. So that's why these things are ordered, you know, Roman numeral 1, look for perfect squares. Roman numeral 2, if it's got a leading coefficient of a 1, look at how you do it in 6.2. Roman numeral 3, if it's neither of those, then you got to go through all that grouping or guess and check method, okay? Then, if it's got 4 terms, use factoring by grouping. Are you through? Well, let's go back and look at this problem, for instance. We factored it, but we weren't through. It factored further. So again, are you through? Have you factored it as far as you can? And then check your work. You'd multiply everything back together and you should end up with what you started with. Be careful that you don't leave something off. For instance, if you did this problem and you got to here, and then you took this and factored it further, but you left that off, that wouldn't be complete. That wouldn't be correct. You want to have your whole answer, okay? The part that I scribbled out there, as well as the last stuff, okay? Let me give you sort of the equivalent in an arithmetic case. Let's say I've got 18, and I'm going to do the prime factorization of it. Well, that's 2 times 9, and 9 is 3 times 3. So is the answer 3 times 3? No.
No.
The answer is 2 times 3 times 3. So you gotta have everything there when you get to the bottom. All right?
All right.
Well, I think that you've had enough of me for today. So I will stop the recording.